Welcome in corridor. Now we are going to learn a new chapter of our curriculum, chapter 3, which is light. Let's start. Here, light is a form of energy, and as you know, the sun is the main source of energy of light on the Earth's surface. Light is an electromagnetic wave that produced from the vibration of electric and magnetic fields. These electric and magnetic fields are perpendicular to each other. The speed of light is the same for all its types, which is equals 3 times 10 power 8 meter per second. From the electromagnetic waves, gamma rays, X-rays, ultraviolet, infrared, visible light, microwaves, and radio waves. This is examples for electromagnetic waves. These electromagnetic waves include these 7 waves, which are gamma rays, X-rays, ultraviolet rays, visible light, microwaves, infrared rays, and radio waves. That's for these points. What about the reflection of light and refraction of light? When a light ray falls on a surface between two media, what will happen? When a light ray falls on a surface between two media, these two media are different in optical densities. Of course, part is reflected, part is absorbed, part is penetrated. So a part of light, of course, is reflected. It's number 1. Another part is transmitted to the second medium. Of course, it's number 2. The rest is absorbed by the atoms of the medium, by the atoms of the second medium. What about the main definitions for these parts? What's meant by angle of incidence, angle of reflection, angle of refraction? Angle of incidence, we called it phi, angle of reflection phi dash, angle of refraction theta. Any angle, it is the angle between the ray and the normal. When I say angle of incidence, so angle of incidence means, yes, angle between incident light ray and the normal line. What's meant by angle of reflection? Angle of reflection, it is the angle between reflected light ray and the normal line at the point of incidence on the reflecting surface. When I ask you about what's meant by angle of refraction, it means, yes, angle between refracted light ray and the normal line. So here, angle of incidence is the angle between incident light ray and the normal to the separating surface. And angle of reflection phi dash, it is the angle between reflected light ray and the normal line to the separating surface. Angle of refraction is the angle between refracted light ray and the normal to the separating surface. That's for these definitions. What's about law of light reflection? Laws of light reflection, we have 2 laws. Number 1, angle of incidence equals angle of reflection. Number 2, incident light ray, reflected light ray, and the normal all lie in one plane. This plane is perpendicular to the reflecting surface, the same such as sound, the same for sounds. Incident light ray, reflected light ray, and the normal all lie in one plane. This plane is perpendicular to the reflecting surface. Okay, that's for these laws. Of course, when you stand in front of a mirror, you see your image due to light reflection. Of course, it's very easy for you. Okay, here as you see, law of light refraction, light ray, and it is refracted. Here it is refracted. Okay, so it is refracted and another part is reflected. Here angle of incidence and here angle of refraction. Angle of incidence phi, angle of reflection phi dash, here angle of refraction theta, which is called theta. When a wave travels between two media, so sine phi divided sine theta, sine phi divided sine theta equals V1 over V2 equals lambda 1 over lambda 2 equals 1 NE2. 1 NE2 means relative refractive index from the first medium to the second medium. 1 NE2 means relative refractive index from the first medium to the second medium. It is a what? Means relative refractive index, and it can be defined as follows. I can say the ratio between sine angle of incidence in the first medium to sine angle of refraction in the second medium, or velocity of light in the first medium, ratio between, of course ratio between velocity of light in the first medium v1 to velocity of light in the second medium v2, or relative refractive index from the first medium to the second medium can be defined as follows. Ratio between wavelength of light in the first medium to wavelength of light in the second medium. Okay, so that's for the relative refractive index. That's for the relative refractive index. What's meant by absolute refractive index? Absolute refractive index, its symbol is N. N equals C over V. C means the speed of light, the velocity of light in free space. But V, the velocity of light in the medium. The velocity of light in the medium. So, absolute refractive index for any medium, it is a ratio between the light velocity in the free space to light velocity in the medium. Which is greater? The light velocity in the free space or the light velocity in the medium? Yes, of course, the light velocity in the free space is always greater than the light velocity in the medium. So, absolute refractive index is always greater than 1. Is always greater than 1. So, please don't forget the meaning, the definition of absolute refractive index. Absolute refractive index, it is a ratio between light velocity in the free space to the light velocity in the medium. That's for absolute refractive index. What's about law of light refraction? About law of light refraction, please don't forget. This give reasons, this very important give reasons questions about the absolute refractive index of light of any medium is greater than unity, is greater than 1. As you know, the light velocity in the free space is always greater than the light velocity in any other medium. So, since N, absolute refractive index, equals C over V, since C is greater than V, so N is, yes, is greater than 1. Here, because the light velocity in the free space C equals 3 times 10 power 8, 3 times 10 power 8 is greater than any other medium, greater than in any other medium. Therefore, N equals C over V, N equals C over V, C greater than V, and C over V is greater than 1. C over V is greater than 1. Another question. The refractive indices have no units. Any refractive index has no unit. Why? Because the refractive index, if it is relative refractive index or absolute refractive index, it is a ratio between two similar quantities. So they have no units. Any relative or any refractive indices have no unit because it is a ratio of similar quantities, because the ratio of similar quantities having the same unit. So each medium has its own absolute refractive index, has its own optical density, so it varies depending upon the wavelength. If the wavelength is too long, so the refractive index is small. But if the wavelength is too short, so the refractive index will be very high. What's about the absolute refractive index or indices of some materials are? The absolute refractive index of the air is nearly equal to 1. Why? Because the light velocity in the free space is nearly equal to the light velocity in the medium, in the air. The light velocity in the free space is nearly equal to the light velocity in air. So, the absolute refractive index of air is nearly equal to 1. As N air equals C over V air. C, V air is nearly equal to the velocity of light in the free space, so c over c equals approximately 1. Approximately 1. That's for this point. Law of light refraction. Law of light refraction. Here the examples for these mediums, examples for the refractive index for any medium, and we can conclude this point. We can conclude this point: sine phi divided sine theta equals v1 over v2 equals lambda 1 over lambda 2 equals n2 over n1 equals 1 n2 equals 1 divided 2 n1, and this is to solve any problem about refraction of light. Sine phi divided sine theta equals v1 over v2 equals lambda 1 over lambda 2 equals n2 over n1 equals 1 n2 equals 1 over 2 n1. From this relation, we can conclude Snell's law. Snell's law, n2 over n1 equals sine phi divided sine theta. n2 over n1 equals sine phi sine theta by cross multiplication, so n1 sine phi equals n2 sine theta. n1 sine phi equals n2 sine theta. This is the Snell's law. So Snell's law, absolute refractive index for the first medium times sine angle of incidence, sine angle of incidence equals absolute refractive index for the second medium times the sine angle of refraction, the sine angle of refraction. So this statement is Snell's law. Examples: if a light ray falls on a glass surface, whose refractive index is 1.5, n small equals 1.5, at an angle 30, at an angle 30 degrees, at angle 30 degrees, calculate the angle of refraction. Of course, as you know, 1 n2 equals sine phi divided sine theta. 1 n2 means, yes, n2 over n1. n1 is the air, is approximately equals 1. n2 for the glass, n2 equals 1.5. Sine phi, yes, sine 30. Divide sine, yes, sine theta. So here it is theta. So we can make cross multiplication. So 1.5 equals sine 30 divided sine theta. So theta equals 19.471 degrees. Theta equals 19.471 degrees. That's for this example. Another example. Given that the absolute refractive index for water is 4 over 3 and that for glass is 3 over 2. Find the relative refractive index from glass to water and from water to glass. From water to glass, so relative refractive index from water to glass means, yes, 1 in n water glass, so n glass divided n water. n glass equals 3 over 2. n water 4 over 3. 3 over 2 divided 4 over 3 equals 1.125. That's the relative refractive index from water to glass. So finally, relative refractive index from glass to water. From glass to water means n water divided n glass. n water divided n glass, so 4 over 3 divided 3 over 2, so n glass to water equals 0.889. At the end, I hope to understood our points for today, and I hope to join us in the next time. Thank you and goodbye.